Identify the underlying chemistry concepts being tested. This question tests your understanding of Coulomb's law and how it governs ion-dipole attractions between dissolved anions and polar water molecules in an aqueous solution. Recall Coulomb's law. The electrostatic force of attraction, F, or potential energy of interaction, E, between two charged species is directly proportional to the magnitude of their charges, Q1 and Q2, and inversely proportional to the distance between their centers, D. F is proportional to Q1 Q2 over D to the power 2. Analyze the effect of charge, Q, on the interaction strength. Water is a polar molecule with a partial positive charge, delta to the power plus, on its hydrogen atoms. Anions attract these delta to the power plus hydrogen atoms. The charges, Q1, of the given anions are chloride, Cl to the power -1 iodide, I to the power -1 sulfide, S to the power 2, -2 telluride, T to the power 2. -2 because charge magnitude has a direct, proportional relationship with force, the divalent anions, S to the power 2, and T to the power 2. With a -2 charge will have significantly stronger electrostatic attractions with polar water molecules than the monovalent anions, Cl to the power negative and I to the power negative, with a -1 charge. Analyze the effect of distance, D, among the divalent anions. For ions with the same charge, we must compare their ionic radii. A smaller ionic radius means the outer shell of the anion is closer to its nucleus, which allows the surrounding polar water molecules to get closer to the center of negative charge. This minimizes the distance D in the denominator of Coulomb's law, maximizing the attractive force. Comparing the ionic radii of the 2-2 anions, sulfide, S to the power 2. 184 picometers telluride, T to the power 2, 221 picometers because S to the power 2 has a significantly smaller ionic radius than T to the power 2. It has a much higher charge density. The water molecules can get closer to its charge center, yielding a stronger electrostatic interaction. Conclude, sulfide, S to the power 2, has the optimal combination of a high charge magnitude, -2, and a relatively small ionic radius, 184 picometers, making it the anion most likely to have the strongest interactions with nearby water molecules. This corresponds to option C. The correct answer is option C, S2-.